Well, welcome everybody. My name is Brennan. Joining with me is Armen, one of our lead data scientists as well. We're with Scylla AI, and today we're going to talk to you just about environmental hazards and what we're doing with next-gen AI technology to help solve these problems on that side. And so, like I said, my name is Brennan Borgestad. I'm one of the business development managers here at Scylla. And then Armen, I'll let you introduce yourself as well too.
Hello to everyone. Thanks for joining the webinar. I'm Armen, lead deep learning engineer at Scylla. I'm responsible for products including anomaly detection system, the sub module of which we would be talking about for this webinar.
Awesome. So just to kind of give an overview of what we're going to be talking about and just some of the environmental issues and just the area of concern of what and why Scylla takes interest in these areas. Some of the big things around what we're detecting and what we're going to be talking about around fire detection and oil spill are a huge issue just in a lot of areas. A lot of the different things with different fines, with just different vapors and the health concerns that could be around oil spills or just even fires and things like that are definitely a huge risk, as well as just things like slip and fall, which we have modules to help detect. But if we can even detect it before from a slippery surface caused by an oil spill or something like that, super important. Smoke and fire as well, just with air pollution and things like that, as well as we've got other environmental hazards just around natural gas and oil being spilled across just the US as well as around the world on that side. Some of the big things too with a lot of the pipelines and things like that is there's just huge annual reportings like the 339.2 billion, 72 billion just in annual costs is just huge. So there's a huge just expense around a lot of these issues that are caused by fires, by oil spills, leakages, and things that if they're not taken care of right away when they appear, can really result in a lot of damages, fines, and things like that as well for that. And we see that a lot of times just in the news, just whether it's in geographic areas like in California, as well as just in areas that are more in that manufacturing space or oil and gas, just different areas too. And so that's, for us, what we're going to be talking about today. We're going to give a little bit of an overview on Scylla and our solution, just for people that are joining. I know we have people from the oil and gas, from the manufacturing space. We have hospitals. We have other directors of security and people that are working in the security space as well. So we'd love to just give you guys an overview of what we're doing, as well as just narrow in specifically on this environmental hazard space and what we're doing to help on that as well. But just to give a summary about what we're doing at Scylla. So Scylla is a next-gen AI solution really focused on real-time threat detection. And so what we do is we add analytics to your existing cameras to help detect objects, actions, and behavior anomalies. And really the end goal is to make your cameras more proactive rather than reactive, where historically a lot of cameras are used in a reactive mode where if something bad happens, it's okay, shoot, let's go check the tapes, let's see what happens. But for us, we want to use our analytics to help alert you in real time to actual threats and objects and anomalies like some of the things we're going to be talking about today in real time for that. And with our system, the way that we're set up, like I mentioned, we work with existing cameras, so we're completely camera agnostic as long as we can capture that stream of the camera. And we are server based, and so whether that's an on-premise server in the cloud, as well as we can work with edge devices like our Scylla Asteria with that as well. We work on powerful GPUs, and by running on that, we like to look at our system more as the Netflix of analytics as opposed to the DVD player of analytics, which we would call more the embedded camera analytics. With those out there, you're really only limited to the processing power of that camera, and it's really solely just rules-based analytics, and you're not able to do some of the more powerful machine learning analytics that we're capable of running on powerful GPUs with that. And the other thing too, with a lot of those embedded camera analytics, you're really only limited to that analytic that you have. So again, like a DVD player, pop it in, it's the same DVD over and over again. But for us, we're constantly getting smarter and smarter, so we're improving our modules, as well as we can turn off and on different analytics depending on the time, depending on the season, depending on just different things that come up in the organization that you're working for, whether it's game days versus non-game days, event days or on hours versus off hours and things like that. There are different security concerns that need to be addressed on that side, and we can help scale it to be exactly the right fit that your organization needs as well too. So just to give a quick overview, we're going to be mainly focusing on the anomaly side, specifically around the environmental hazards and what we're detecting there. But just to give you an overview too, for anyone new listening into what Scylla is all about today, we're also able to detect things like objects, so things like guns, knives, helmets, and face masks. So that's both for things of like detecting a weapon or a motorcycle helmet if someone walks into a building, but also for like PPE standards for face masks or hard helmets in a manufacturing space. We're able to detect that. We also have the ability to work with cameras like the M16 Mobotics camera and do on-the-go thermal screening with that as well. We also have intrusion detection and perimeter protection, where we're looking for only people and or vehicles and filtering out all the other false alarms, whether it's raccoons, branches moving in the wind, or anything else like that. We also have the capability of using facial recognition for letting people in and out of the building with just kind of employee access with using their face, as well as too for be on the lookout list, as well as too we have the ability to track people based off their physical appearance. So whether that's a gunman, whether it's a be on the lookout threat that we want to know about, or even just a missing person or a missing child at an event too. So we have that capability as well. Like I mentioned, we also have our Scylla Stereo, which is our edge solution as well for that. And if anyone's looking for a better remote solution, especially for like a remote parking lot or a remote site, if you have individual sites, we'd love to give you some more information about that, and feel free to reach out as well too. And then we also have the ability to work with moving backgrounds too. So we can work with drones, moving PTZ cameras, as well as body cameras, anything like that. So we're not limited to just fixed backgrounds. We can also work there on that side too. And then we also have then our anomaly detection and behavior recognition, as well as environmental hazards and detection. So both of these are anomalies that exist. The anomaly detection portion, we cover things like fights. We also then have slip and fall, as well as retail crime for shoplifting and things like that. And then on the environmental hazard side, which most of our conversation today is going to be focusing on, we're able to detect things like fire, smoke, oil leakage, things like that, anything with gas leakages or things like that as well for that. And both the way that these modules act are going to be similar, and Armen's going to go a little bit deeper into that as well, but that's what the majority of our conversation is going to be focused on today. Yeah, so we're going to kind of go over just the difference between anomaly detection and object detection. I'm going to let Armen take this, but again, too, just another note, if anyone just joined, feel free to add any questions that you have about the Scylla solution or how we're set up on our environmental hazards detection. For that, feel free to put that in the Q&A section, and we'll make sure to get through those questions. I have these popped up on my screen, and would love to help answer any of those questions. So Armen, I'll let you kind of go over just the difference between the object versus action and how we're detecting those differently.
The main difference actually is in regards to the number of the axes dimensions you are analyzing. In case of object detection, like computer vision based, like deep learning solutions or deep learning solutions for computer vision that try to identify or detect an object, usually they use a single frame per time to detect the object. But when we talk about the actions or like environmental events, there are the things that are a little bit hard to differentiate when you look only to one single frame. So if you look at the example presented in the slides, you can see that there are like a group of people. From a single frame, it's a little bit hard to tell what is like actually happening. Maybe they are like celebrating something, maybe they are hugging each other, or maybe they are fighting. So if you don't have the time sequence of the frames, or otherwise the video event of the frame, it's pretty hard even for human eye to tell what is going on there. This is like basically is related to human action recognition or behavior recognition, for which we need this time dimension to efficiently and accurately detect whether this or that event of interest is happening or not. But surprisingly enough, or maybe not surprisingly, in case of environmental hazards, the same logic is being applied. So imagine there is like smoke or fire. During there are many situations where if you analyze only a single frame, there might be some like lighting conditions or like car pollution condition, sunlight reflections from the windows, especially when like visually from a single frame, it's impossible to differentiate whether it's a smoke, fire, something dangerous or something normal. That's where the motion analysis full time is coming into use, because when you analyze the motion of the event that you see, like smoke and fire movement is different from like ordinary light movement, That's where we are able to make this differentiation and balance between these true positive and false positive signals. By balancing, I mean like reducing the false positives and increasing the detection rate of true signals. Brennan, if I ask you, can you go a little bit forward?
Yeah, absolutely.
So these are actually like examples again that from a single frame, it's almost impossible to be sure what is going on there. You need the time information. But there is one trade-off. When you use a time domain, it means you are using a lot of images because like video consists of these images. And there is a trade-off of hardware requirements and increase of the accuracy. So what we have done in Scylla, we have developed smart algorithms that efficiently sample from the video the frames that are the quantity of which is enough in terms of guaranteeing high accuracy to detect the event. And if you go forward again, so what intervals, what time intervals we are analyzing? For events like behaviors like fights, abuse, or shoplifting, it was statistically derived by our team that like 2-3 seconds is sufficient enough to detect whether there is a fight, and it's on average statistically enough to tell that there is a fight going on or shoplifting going on. For environmental hazards, again, to balance out true positives and false positives, we have determined that 4 or 5 seconds are enough to be able to, with high probability, with high like confidence, predict that there is that particular event of hazardous environmental some activity happening. We also differentiate between red and yellow alerts. So the logic is actually pretty simple. There is a red alert, which has a predefined threshold, some static threshold, a high one, again, to balance out true and false positives. If the model produces an output in the form of probability, which is higher than the threshold, then we immediately trigger the alert. In case when the event is happening on a far distance, and it's like visually not that much simple to see whether the event of interest is happening or something different, which is like normal for like environment and the context. So we have developed also the yellow signal triggering, which is the case where the model detects something, but it's not detecting with high probability. So there is a weak signal coming from the model. It's not passing the threshold that we have set, but still the signal is persistent. So if the signal is too much persistent through time, in that case, we trigger the yellow signal, not to miss anything which is like not as much visible, but still there is something to look at in any case. So if we go forward.
Just one of the notes too, Armen, too. Yeah, so with kind of going back to the fight side, for example, like with our gun detection being an object detection module, one frame alone of me holding a weapon or me having a face mask on, as long as it's visible, we can tell, in a human eye even too, they can tell, okay, there's a face mask or a gun. But things like a fight or even a fire, things like that too, one frame alone doesn't really tell the whole story, where there could be an image of Armen and I going in to shake each other's hand. And from one angle of a camera, it actually looks like we're shaking hands, but the other angle, it actually looks like one of us is trying to hit the other person or things like that too. That's really where our anomaly detection differs and where we get our accuracy too, like Armen was mentioning, is adding that added value of time to properly say, hey, is this truly a fight? Is this truly a slip and fall? Is this truly a smoke and fire incident or oil leakage at a pipeline or whatever it might be on that side too for that? And so that's where that added value of time really just gives us more accuracy in our system and on our analytics too for that. So perfect. So here, yeah, Armen, I'll let you go over to just some of the stuff with our environmental hazard solution as well too.
So yeah, basically, I would like just to list out like what type of environmental hazardous events we are detecting, our system or sub-module is detecting. This includes smoke and fire, oil and gas leakages. Thanks to the power of deep learning, and the way it is being trained and the way it is being to be able to generalize given sufficient amount of data, we are not sensitive to indoor and outdoor environments in terms of smoke and fire. So it works in any environment. The requirements are like simple. You need just a camera which with a like good network connection to have the streams not interrupted, since like what we are analyzing the motion. If like the stream stops, it's the same as analyzing image, because we get like the same image. So the motion is important in this case. The solution is also pretty scalable, especially if like you compare the domain of video analytics, which is like pretty high in terms of hardware requirements. Because again, we are not analyzing a single frame. There are like there's a huge amount of information speaking like digitally that we are analyzing through time, through this like 2-4 second interval. And the system can be modified to be able to work on top of object detection. So first, like we detect the area with the help of object detection, and then we concentrate the ADS module on that particular area to make the inference and to increase the detection rate.
Awesome. And some of the things too, yeah, with our hardware as well, is we are very we do need hardware. We need to make sure we have the GPU set up, but we're still very efficient in our hardware usage for that compared to a lot of competitors, as well as too on the pricing side. We want to be as scalable to exactly what you guys need, and be as efficient too with the hardware that we're using for that as well too on our system. Awesome. And I see a couple questions too, just quick to pause real fast, Armen. Oliver, I see, can we get a copy of the presentation afterwards? Anastasia, if we can send this out, yeah, the PDF, we'll have this recorded as well too and posted, but then the PDF as well, we'll make sure to get that over for that, Oliver. And then I see also Jason too. Does your system, upon some type of pre-programmed detection, immediately notify authorities, security, and or stakeholders via text or email? So just one kind of quick note too, Armen, apologies, just to go over on the system, the way it works. So we have our own dashboard for that, and you'll see some of that in some of the videos coming up here, where this would come up to the video front if you had our dashboard popped up in the security suite or however that was set up. But then we can also customize the alerts to go out. We have our own mobile applications for iOS and Android to be sent out that way. We can also customize the alerts to be sent via text or email, as well as too, if it's something very serious like a large fight or a weapon or even a fire as well too. If we need to get emergency authorities or things like that too, we can work with different applications like Intrado, Intrepid to do mobile 911 dispatch or things like that too. And so we have a lot of different workflows, and we can definitely scale and scope to exactly what you guys need for that. Because like what I tell a lot of customers, we have really incredible analytics, but we want to help give you just a purpose with them too, because of the analytics alone, it's just really cool, nice to have, saying, oh cool, you spotted a fire, or you spotted a weapon. But we want to help make workflows for you too, to say, okay, what are you going to do if you see a weapon or if you see a fire, and make sure it's actually applicable and something that we can be used proactively in your company as well too for that. Awesome. And we've got one more question as well. How much time would we approximately need to get enough data on identifying oil spills at an airport when it rains, and at seaports when seawater color can vary during the day? Armen, I'm going to let that one go over to you on that side.
Mm-hmm. So basically, we can like install the base model, and if there are like some environmental specifics that can cause higher number of false positives, we can like the model can be self-adjust on that information, and after that it will differentiate, which for human eyes looks like pretty similar to smoke and fire from the actual smoke and fire. It takes first of all, like the model needs to be like calibrated on site. If like everything is okay during like several hours or like 1 day, 2 days, then there is no need for calibration. It means that the generic data set that the model was trained on is being able to differentiate, not to mix like the events that are similar. Or otherwise, in case of higher than accepted amount of false positives, we can easily readjust the system. The other thing is that also the sensitivity regulation through the thresholds. So if like you want like more rigorous signals, you can just increase from the dashboard the threshold, and the model would like lose some of the sensitivity, but it would be triggered on like more like extreme situations of the environmental hazards.
Awesome. Perfect. Well, Armen, I'll let you kind of go into just how it works too with the environmental hazards and some of the stuff on this slide too.
Yeah, so as already stated, the solution has been developed to help users to effectively address a variety of environmental threats, including smoke, fire, oil and gas leakages. We are using like state-of-the-art computer vision and AI technologies to constantly like perfect the solution, increase the accuracy, and make it less hardware, like to decrease the hardware requirements for the system and increase the overall user experience for the model to interact with. Right now, if you can go to the next slide. Right now, like we have achieved. Right now, like here is the look of the mobile dashboard, where you can see that after like making the detection, we visualize the area where like the model thinks that the event, hazardous event, is happening, and we also return as an alert video, like both the video on the location where the event has been detected on the video. If we go to the next slide, there is like also mentioned the current system accuracy. So we have achieved almost like 95% accuracy for the event of smoke and fire. It's a pretty good result in terms of like the balance between true positives and false positives. The detection rate is pretty high, and the amount of false positives is pretty low, like compared with other solutions, especially.
Awesome. And that's a big thing too, with us being machine learning in a true AI too. Again, we're constantly updating the data sets, improving the modules, and sending those updates on a constant basis too. So the system's getting smarter and smarter, as well as too, Peru, just for your question too. And there's certain areas that are unique to an environment like an airport or things like that, where we start getting some false positives as well. We can start either one, changing the threshold, see if that fixes it, but then also two, actually train the system to say, hey, no, we want you to differentiate from this incident versus an actual smoke and fire or oil spill or whatever it might be as well. So we can constantly get smarter and smarter on that side. It's just a means of data, getting the data and getting those updates pushed out to the system as well too. But yeah, so just a little bit of a demo too, Armen. I know you're starring in this feature video too on this side, but just to kind of show you the difference in how our analytics are working and differentiating between things like just simply light versus fire on this side too. Here, I'm going to go back just so it loads properly here on this side.
So this is actually the thing we're talking about, like one frame. If you see like from one frame, the light looks like pretty similar to smoke and fire. So this is the way to demonstrate how like we are not triggered by this type of events that look pretty different, how we are triggered with this type of events. So it takes time for the dashboard like to analyze the system, since like we are analyzing 5-second intervals. So like 5 seconds needs to be passed from the start of the event. Then we analyze it and send to the dashboard if we believe that the event was too much similar to the smoke and fire, according to the outputted probability.
Yep, perfect. And so that's the thing too, yeah, is with the dashboard, this gives you a little bit of an idea of what our dashboard's looking like too. So again, these alerts would come up in the detection side, but then we can also customize those. Jason, to answer your question too, we can customize these alerts to then go out via mobile application, or even send them via text or email or however we want, or even route them to emergency services through like mobile 911 dispatch applications as well too. for that. And so we send out alerts. So we either send you a video and or a photo with the zones drawn out as well for that, and make sure that you're getting alerted in real time. And the correct people are also getting alerted too. And that's something that we work with to help scope out exactly what you guys want to see. So for things like weapons or fire, this is a huge thing that security needs to be notified of, or if there's a private fire department or things like that need to be notified of on that side. But then things like slip and fall in a hospital or something like that, those can be notified to the nursing staff or things like that, or in an office building. They can be notified on the front desk of things like a slip and fall for those sides. So we can customize which alerts go to which people on the dashboard and on the mobile applications too, of who's getting these alerts in real time as well too. Perfect. So if there's any questions too, feel free to put those in the chat. We're gonna actually pull up to some different videos as well of the system, just to kind of show you some of the other things with the smoke and fire side as well. This is actually a gas station scenario. Perfect. Dennis, I see you're saying, is it possible to detect gas leaks in the future? It's actually now that we're able to do that. Yeah, let me show you in a little bit. That'll be our next video here too. So this is just at a gas station, the fire detected on that side. These alerts, and we're constantly pushing out these alerts as long as we're seeing the fires come out, and just the crazy then explosion of the extinguisher too on that side, and the smoke coming from that on that side as well. We've got, this is an example just to kind of show you a real case, one on that side, as well as then two on the oil gas leak. So this one's a unique one too, where a fire, there's a lot more commotion going on with that, where you see this right away. In this case, you'll actually see this part right here is going to start getting more and more yellow, and you'll see the gas coming up. That's where we're analyzing that. We're starting to see some of the changes in this. And again, one frame alone is not going to tell the whole story, because it looks like, oh, it's just a brown piece of mud or dirt over there. But because we see the actual change going on in this system, we're actually then able to analyze and start sending out some early alerts of this for that. And that's a huge thing in the oil and gas space and manufacturing, just if there's any oil or gas spills too, where some of these, a lot of these instances, again, there's obviously some that's leaking and spilling now, but a lot of these go undetected for 24+ hours until someone makes their rounds and actually checks out the plant for that. Whereas if we can get these notifications out in real time, we can then get someone out on site within 5-10 minutes, 20 minutes, depending on kind of where their location is, and have them then shut off the valves or whatever they need to, so that way there's not a bigger kind of disaster with that side too for that. So again, we're analyzing this. The thresholds we set specifically for this to say, hey, if we see anything around this area, and again, we set up the modules to then be looking for the oil spill here. So you can see it turning more and more yellow, especially compared to the beginning where there's nothing, it was just the same color. But then by the end of it too, we're starting to see more and more the color change, and it's spraying out for that too. And we, like Armen mentioned too, we have the yellow alerts and then the red alerts too. And so we can kind of touch on the thresholds too, to say, hey, we want whoever's behind the security desk to know about all of these, but then we also want to know about a lot of these other ones as well too. So if it gets more and more intense and serious as well. But awesome. Jason, looks like, yeah, would like to connect, send a LinkedIn request. Perfect. Yeah, would love to connect and chat some more too for this as well. Any other questions too, feel free to pop them in the chat or the Q&A for that as well.
So as I mentioned, like we constantly, yeah. Okay.
I was just saying, yeah, Chris, and I believe Anastasia's typing this out. We're going to share the recording as well as the presentation. Sorry to cut you off, Armen. I just saw Chris added a question here as well too.
So what I wanted to say that I already stated one time that there is a feedback loop inside the system, like developed inside the system, and through the feedback loop, the system readjusts itself to the environments it is being deployed to. So there is like a base system, which is, if it's okay, like the accuracy is fine for that particular environment with like corresponding streams, then it's okay. If like the false positive rate, there is a need to reduce some false positive rate, which is like from the base model is pretty low, but if like we want it to make even lower, it can through the feedback loop be readjusted to make it even more perfect for that particular environment.
Awesome. Perfect. Well, with that, yeah, if there's any other questions too, feel free to connect with either one of us. Again, Brennan, Borgestad, and Armen as well on LinkedIn, or ask some questions, or as well too, we have our contact information, the telephone, and email too. Feel free to take a screenshot. We'll make sure to send this information out as the slide decks, as well as to the recording of this. It should be popping up and going to your inboxes as well here shortly. We appreciate you all taking the time to hear about our solution, and look forward to making the world a safer place and a more proactive security environment. Thank you guys so much.